In this video, we are going to do another probability example that involves complements. So the example says that two fair 12-sided dice, numbered 1, 2, 3, up until 12, are rolled. What is the probability that the sum of the rolls is, in part A, 4? So normal dice have sides numbered 1 up to 6, but these are 12-sided dice, which is why they have more numbers. So, for example, to get a feel for how we're summing, we're going to have, let me just keep track of the first roll, the second roll, and the sum, and do a couple of quick examples. So let's say that the first roll is a 4, and the second roll is a 9, which could happen because the dice are numbered all the way up to 12, actually. So then the sum would be 13. Or if both the rolls are 1, then the sum would be 2. So, okay, we want to know the probability that the sum of our two rolls is equal to 4. So if I set up a fraction for our probability, on the top, I need to count the number of successful outcomes. And we have a success if the sum is 4. So the top is the number of ways to sum 4, to sum up to 4. And on the bottom, I need the total number of outcomes. And in this problem, my outcomes are the different ways we could roll these dice. So the total number of rolls. All right, so for the numerator, let's think about the ways that we could sum to 4. What are the different combinations of the rolls that will give us a sum of 4? Well, we could do 1 and 3. We could do 2 and 2. Or we could also do 3 on the first one and 1 on the second one. So overall, there are 3 ways to sum to 4. All right, so the numerator is 3. And on the denominator, I need the total number of rolls. So there are 12 sides to each of these dies. So there's 12 choices for the first roll, 12 choices for the 12 choices for the second roll. And again, this is coming because there are 12 choices for each roll. And that gives us 3 over 144. And that is our probability. All right. So let's up the difficulty a little bit. Let's do part B, which now asks, what's the probability that the sum of the rolls is greater than 4? So we want the probability that the sum is greater than 4. So if I set up my fraction for probability, on the top now, I'm going to have the number of ways to have the sum be greater than 4. And on the bottom, I'm still going to have the total number of outcomes, which is the total number of rolls, because the rolls are the outcomes in this problem. Okay, so I'm going to think about this in 2 ways. I'm going to think about it first. I'm going to call this approach 1. And approach 1 is going to be a direct approach. Because there's many possibilities if the sum is greater than 4. There's so many things that could be. So the fact that the sum is greater than 4 gives us cases. So one of the cases, what's the smallest the sum could be? It could be 5 if the sum is greater than 4. The sum could also be 6. And I could keep going like this. The sum is 7, the sum is 8. And the biggest the sum could be is if both of the rolls were 12. 12 plus 12, which would be 24. Okay, so we're definitely going to have a bunch of cases. I'm not even going to bother numbering this last one because we have a bunch of them. So this process of doing it directly definitely looks tedious. And usually when something is tedious, I'm going to draw a sad face. Ideally, we would like if there is a more efficient way of doing this. So often when we try to count something directly, and it's either hard to do or tedious to do, we try using the complement. So that's going to be my second approach. So approach 2, direct approach seems tedious, very tedious. In fact, there's so many cases. Let's try complements. So I want to give you the opportunity to try this first. So we are focusing on this numerator right now and trying to count the number of ways to have the sum be greater than 4. And counting that directly wasn't, it was tedious. So we're thinking to use the complement. So I want you to pause the video and try to count the number of ways for the sum to be greater than 4 using complements. And try that for about 3 minutes. 4, 3, 2, 1, pause the video. Pause it and try that for 3 minutes. That may not be enough time to finish the question, but hopefully to get thinking about like what are the key ideas, how I would get started, and that sort of thing. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. So we want to count the number of ways for the sum to be greater than 4. So if I think about this visually with a Venn diagram, so visually, I'm going to draw a circle for my set here, which is where the sum is greater than 4. And let's draw that in a big universal set. And the universal set is going to represent all of the outcomes. And the outcomes here are the different roles that we could have. So U is the set of all roles. So what we're going to do is to count the number of elements in this circle, we're going to count first the number of elements in U, the total number of roles, and subtract away the complement of this set. So if I call this set A, and then I write what A complement is out here, the complement of the sum being greater than 4 is if the sum is less than or equal to 4. So I'm going to subtract away the number of ways for the sum to be less than or equal to 4, because that is A complement. Okay, so let's see if we can work this out. So this is going to be equal to total number of roles. Well, we've done that before. There's 12 choices for each role. So we get 12 times 12. And then minus the number of ways for the sum to be less than or equal to 4. So there are a few cases we have to consider there if the sum is less than or equal to 4. We could be counting the number of ways for the sum to be equal to 2. We also need to count the number of ways for the sum to be equal to 3, plus also the number of ways for the sum to be equal to 4. These are all disjoint cases, which is why I can just add up the number of elements in each of those cases. Okay, so this equals 12 times 12 is 144. And then minus, and we got to count how many ways for the sum can be 2, the sum could be 3, the sum could be 4. So let's do that on the side here. I'll make a table of the sum and the roles that give me that sum. So I want to know when the sum is 2, when the sum is 3, and the sum is 4. So the sum could be 2 only if the roles are 1 and 1, if they're both 1. It could be 3 if I roll 1 first and then 2 after that. Or 2 first and then 1 after that. It could be 4. I think we might have already done 4. It was if we did 1 and 3. That was part A actually, to do sum being 4. We could do 3 and 1, we could switch their order. Or we could do 2 and 2. Alright, so the number of ways the sum could be 2 is, well, there's one way to roll it. Both of the rolls got to be 1. Plus, for the sum to be 3, there are 2 such rolls. And for the sum to be 4, there were 3 such rolls. So we get 144 minus 6, which is 138. Okay, so at this point we know what the numerator of this fraction is. Number of ways the sum could be greater than 4 is 138. So we are ready to write down our probability. So the probability that the sum is greater than 4 is equal to The numerator is 138. That's the number of ways the sum could be greater than 4. And the bottom is the total number of rolls, which was 144. Let me highlight that as well. Total number of rolls. We'd even written that out here. Total number of rolls, total number of rolls. And this was the denominator we were after. Total number of rolls. Okay, so we get 138 over 144. And I could simplify this fraction a little bit because I could divide the top and the bottom both by 2. And if we do that, we get, let's see, 69 on the top, 72 on the bottom. And that is our probability.